Hi, my name is Manogna Venla Ramreddy, and the project I've built is object detection using YOLO for bottle and tin identification. And my main objective is to build an object detection system capable of accurately identifying bottles and tins in images. And the technologies I've used are YOLO 8, and I used Gradio for creating a user-friendly web interface, and I also used PyTorch for model development and training. First of all, I uploaded the images and labels in my Google Drive, and so that I can directly get them from here. And images I have testing, training, and validation images, and in labels I have the annotated images of all testing and training and the validation. So after importing all the required data into the Google Drive, I I use the dataset, custom dataset, as I already mentioned. And for the pre-processing, I resize the images to a consistent size of 640 by 640 for better model performance, and and also for the normalization of image pixel values. And the dataset split into training and validation sets for model training and evaluation. And I install all the required libraries for the project, and for the model architecture, as I already mentioned, I used YOLO 8, a deep learning based object detection model. And for the key features, the main key features of this is it efficiently object detect use it has the efficiency of object detection with very high accuracy, and single stage detector, making it faster compared on traditional models. And the model input, as I mentioned, I used 640 by 640 pixels, and for the confidence threshold of zero point 0.8 to reduce all the false positives. Then the model output is annotated image with detected objects, including class labels and bounding boxes, which I'll be showing later in this video. And I did hypertuning also, and for that I used the batch size of 8, which is chosen by GPU memory considerations. And for here I used Epoch 50 to achieve good balance between model training and performance. And the learning rate is tuned for optimal convergence. And for the threshold, as I already mentioned, I used zero point 0.1. And here I used freeze equals to 10, and I froze 10 layers, which we will be seeing here. Here I froze the freezing layer model 0 to model 9. So these layers are freezed, and then the epoch runs for 50 epochs. And if we can see from here, so the images are and all the data loaders are loading, and then the epoch 50 epochs are ran here for better model performance. And and we have optimizer script. And also here, when we see the model summary, we have 168 layers. And with class, I have two classes, bottle and tin, and also third class is all, which has both bottle and tin. And when we see here, the evaluation metric MAP 50, uh, which is mean average precision of 50%, IOU is 0.991 for all, and for the bottle is 0.99988, and for tin is 0.995, which is almost is equal to 1. And for the class-wise performance also, it is really very good and predicting the tin or a bottle. And MAP 50 to 95 is 0.865 for all classes, 0.873 for bottle class, and 0.857 for the tin class. And the reason, and then I installed Gradio. So the reason I installed Gradio is that it is a simple web interface built using Gradio, allowing users to upload image and get predicted from the training model. And the interface provides the image upload. Along with that, uh, the predicted output will be annotated image with the bounding box, which I'll be showing here. And the model metrics here is will be getting MAP, precision, recall, and F1 score. So when I ran this Gradio, Yeah, as I mentioned earlier, the model will be saved into Google Drive, the updated model all the time. And when I run the Gradio interface, so here, yeah, when I ran it, I got the link. And when I click on the link, it redirects to the Gradio.live page where I can drop a image. So here I'm selecting a image from a validation dataset and I'm dropping it here. And yeah, this is the so we can assume we can get that this is the bottle. And when I submit it, the Gradio Live is detecting whether it is bottle or 10. And yeah, here it is detected it's bottle. And the MAP is 0.995 and the precision recall F1 scores are almost equal to 1. And the accuracy is also equal, is almost 99%. So here the model detected that this is the bottle. And along with this, I also want to show yeah, the validation metric and test metrics. When we compare the validation and test metrics, it's almost equal. And here validation metrics for MAP 50 is 0.99 and 50 to 95 is 0.91 and precision are and recall are both almost equal to 0.9 and that is equal to 1. And same with the test metric also. So yeah, and here I also made a plot show of before training sample and after training sample, and I chose two samples here. So before training and this is after training, it detected that this is the bottle, and here also detected that this is the bottle for the sample two also. So I want to conclude this with that the model successfully detects bottle and tins with high accuracy of 99% and excellent performance metrics. And the Gradio interface provided a easy to use way to interact with the model for real-time object detection. Yeah, thank you.